We've all been there, in the middle of a job, everything going smoothly, until boom, you're missing a part. United Refrigeration is your one-stop shop for all your refrigeration needs. Use your computer or smartphone to go to www.uri.com at any time of day or night to check stock on your favorite brands, such as Copeland, Sporlan, Carlisle Compressors, Danfoss, Emerson CPC boards and sensors, Carrel, Hussmann Parts, and K2Therm. United Refrigeration Inc. is home to these brands and many more. Looking for information on refrigerant conversions or refrigerant banking? Quick access links on the homepage can get you to the information you need. All approved accounts are able to see live to-the-minute inventory and pricing. Product not in stock at your local branch? No problem. Use the Nearby Stock feature to find a local branch that does have what you need. Are you looking for a branch address, phone number, or after-hours number? That's all available as well. Just click on the branch locator and search for your local branch. Have a model number and looking for a replacement part? www.uri.com/ARP has a vast list of quick pick replacement parts. Just search for the model number of the equipment you're working on and click the Replacement Parts tab. If you don't have an account, click the Register button and we'll have you online in no time. With more than 400 locations in North America, each United Refrigeration branch is fully stocked for immediate pickup. Our branch employees have in-depth technical knowledge, so we can help you get what you need when you need it. Visit your local store or www.uri.com/ARP today. United Refrigeration Inc. has all your solutions down cold.
John, how can you always have the right TV for the right application without carrying hundreds of valves on your truck?
You can carry the hundreds of valves on a trailer behind your truck.
That's too funny. That would work, but how are you going to do that? Maybe there's an easier way.
You can use Sporlan's interchangeable cartridge style Type Q and Type BQ TEVs. Type Q is a conventional design and Type BQ is a balanced port TEV.
Well, come on, I need easy. How easy is it?
Easy as 1, 2, 3.
And it serves thousands of unique applications. So what's the process? How do I put this together?
First, you select the thermostatic element assembly. Then you select the body that you need. Then you select the right size cartridge for the application to get the proper capacity TEV for your application. And then I guess it should also be said you want to actually assemble those into a single valve.
That'd probably be a good idea.
Indeed.
These easy to select and assemble valves mean you're always carrying the right valve for the right job then. If folks want to learn more, what do they do?
You can go to sporlan.com and find more information on the Type Q and BQ thermostatic expansion valves.
I guess that's Jim and John for Sporlan signing off.
How's it going, everybody? And welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. Where are you at this week, man?
I am at home.
What do you mean home? You don't get to be at home.
What's that?
I said you don't get to be at home.
Well, apparently not. I'm at home dealing with all kinds of tomfuckery.
Ooh, that's the most fun kind. What kind of tomfuckery?
You know, I spent my whole day piping condensers in a crane yard next to a garbage dump a day, so I'm just thrilled.
Oh, that's like a bunch of supermarkets down here in Houston. I don't know what it is. Like every rack is obviously near the dumpster, so hot dumpster fire with really, really hot Houston humid weather, so it travels. It's fun.
That's disgusting. Like it was only like 65 a day, so it wasn't like horrible, but I can only imagine working at this place when it's like 80 or 90.
It's probably like working like Chicago in the middle of summer, no?
Well, it's where I am. Like I'm in Chicago basically. Like I'm on the train yards like outside of Chicago, so we're out there flipping condensers over and piping them. So it's always a treat.
Are they still doing regular gas coolers out there, or did they actually switch the Abatic yet?
These are condensers for racks that are clapped as shit, not new racks. Like these are condensers that were 20 years past their prime. They're getting changed.
Gotcha. I didn't know what you worked on.
Probably increased like 15 times more because I mean I'm sure there's about 70 pounds of calcium per fan bank.
Find out when you drop the old one when you're getting it off the crane.
When
Let
he
him
goes to
drop it at the
drop it.
fucking bottom.
When he goes to pick it up and it's like a full 1,000 pounds heavier than the one we're putting up there.
Why does it sound like it's cracking? It's all the calcium just fucking cracking off.
Calcium, you know, don't knock all that out. That's the scrap value going away.
Go gentle. I need that. I need that extra 1,000 pounds. Is this all copper and steel? Yes, it is. Take it away.
So it's funny, like if you bring some cutoffs in and they the HXP copper.
Well,
But what are we talking about tonight?
we're going to talk about gas coolers. I think I had a really neat idea for an advertisement that I'll talk to you about later. But
Oh God.
gas cooler, it's going to be amazing. It's going to be awesome. So yeah, we're going to talk about gas coolers today.
All right. So I guess we'll go over different types of gas coolers.
Sure.
So I'll take the lead.
You
So
want to talk about the control first of what we're trying to maintain? We're going to do the whole thing and not just the operation of the water, right?
we do both. We do
All right.
the pump and dumps and the normals.
And the Bach.
I don't know what that's not how you say it.
I know it's BAC.
From America.
Merca.
from your backyard.
I'm an America inside America here.
All right, guys. So gas coolers. Why do we call it a gas cooler? Okay. Probably 70% of this thing's life, it is a condenser. That's what it is. It's a condenser. It's condensing liquid. Okay.
Unless you're in Texas, then
Unless
maybe
you're in Texas,
60% of the time.
Yeah, I would say probably less than that. You live in Satan's asshole. I mean, the hotter you are, if you're above 87 degree condensing, is a gas cooler. All it's doing is rejecting heat to the outside air. So anytime the CO2 condensing temperature rises above 87 degrees, whether it be 77 degree outdoor ambient, whatever the TD is, I mean, usually it's like, 5 to 10 degrees. So 77 to 80 degree ambient you're going to start to run transcritical. So at that point, it's no longer condensing liquid CO2. It's just making a transcritical fluid, and it has to be remade into CO2 via the rack and manipulation. Now, anytime it's below 87 degree condensing, you're actually making liquid CO2. Yeah, we got to reduce the pressure of it and manipulate it a little bit still, but to make it workable for what we're doing, but it's still condensing liquid CO2, just like we would a normal refrigerant. By dropping the temperature below saturation and allowing it to subcool and allowing it to reject heat to the outdoor ambient. Now, when we're transcritical, though, all we're doing is rejecting heat. It can reject all the heat at once until it gets that saturation temperature down, that pressure down below that threshold. It technically is still transcritical. So you could be running 1,400, 1,500 pounds and be semi-close to ambient temperatures, but still not a liquid because we're a transcritical fluid. It is not a true, there's no PT relationship above that. It's lost that PT relationship.
It's essentially a Schrodinger's cat of refrigeration. We don't know what state that actual refrigerant is actually in there. Could be a gas, could be a liquid, could be a plasma. We don't know. It's a mystery. That's why they come up with that fancy algorithm to kind of guesstimate, what the actual saturated is. That's how the 326, that's how the iPro works. They're basically trying to maintain that 3 to 5 degrees of subcooling coming out of that gas cooler. So you got two things going on with the gas cooler, right? You have, trying to maintain, typically, 5 degree TD on the abatics, so the BACs and the Guttner. And then you have the regular dry, I'm going to call it a dry gas cooler that has no water applied with it. The TD on those, Kevin, those are about what, 10?
On the dry ones, it depends. 5 to 10. They say 10, but I mean, the one I just started up was like 4.
Oh, that's not bad. So, like Kevin stated, as long as we don't get to that super critical point, which is 87.8 degrees, so let's just call it 88 for the Back to the Future effect. So, if we're at 83 degrees outside ambient and we have a 5-degree TD, we are not going to make. We're going to be super critical, right? So, anything below that, it gets down to 82, 81, then we still technically would be running subcritical, as long as everything's clean, everything's operating on these gas coolers. So, Kevin's used to, because he's in a colder climate, he's dealing with just the regular dry coolers that have no water being used whatsoever. Do they struggle a little bit when it gets super hot there in Chicago?
I mean, a little bit, but I mean, most of the struggle that we see with those CO2 racks is all flash tank programming and the 326 programming. Once
Okay.
that's taken care of, I mean, the gas cooler usually does okay. Other than that, I mean, we only have what 2 stores in Chicago that are adiabatic.
Really?
Yeah, all of our stores are gas coolers.
The reason why we run the Abatic is to get a lower TD on the thing. So by running, basically the way these Abatics work, there's a filter style material that's in the front. It looks almost like if anyone's lived in any colder climates, humidifier panel. That's essentially what it looks like. I don't know if the coating is the same. Some are coated blue, some are coated like a tan. Those are a water panel that basically water is drizzled over there. And each gas cooler has its own idiosyncrasies about it. But basically, the principle is that we're by dropping water across it, we're actually dropping the dew point of the air, which means that we can achieve a little bit more cooling out of that gas cooler, because the essentially the air temperature, for all intents and purposes, is a little bit lower than what it would be if you're just using regular fans across it. 99% of the time from here on out, all the fans on the gas coolers, preferably like to be either VFD driven or they're the MPATS motors, right? So you can get a little bit more control out of it because, the more variable load that you can take off and on there, the better control you're going to have.
Here is my bitch about that entire thing, my rant. These MPAPS motors, okay, it is possible to cycle them, but all these manufacturers do not send anything set up outright, set up to actually cycle these. It's quite easy to cycle these just with you don't even need a bunch of AOs. You just need 2 AOs. You just need a relay board and 2 AOs. One AO, it's a constant 10 volts, and one AO, it's your signal. And you could literally cycle the AO to shut fans off. Because here's the problem with 90% of these racks in the wintertime. Okay, so you have a minimum speed on those individual fans. Okay, well, they're all tied together.
Mm-hmm.
When you start 5 fans at the exact same time, what's going to happen to your rack if you're running enough drop leg temp?
Oh, it's going to dump.
It's going to dump.
Yeah.
We no longer run them off drop leg temp. We run them off pressure.
Oh, okay. Even if you put a minimum on there?
So what we do is we run them off. I run them off TD, and I run them off of. I'll put a minimum saturated temperature, 40 or 50 degrees, and then I'll put a maximum of. I'll make it so it's 85, 86 degrees, and then I put the fast reclaim at 1,100 pounds. So when it gets fast recovery, when it gets to 1,100 or 1,200 pounds, the fans are running full bore.
Okay.
You lose a little bit. You use a little bit more fan horsepower this way, but I'll tell you what. I'd rather have some fans, ECM fans, running full bore that barely pull any amps, and then keep that other 40 horse compressor off.
True, because obviously the lower your saturated condensing temperature is, the bigger your compressors appear. So it's less compressors that you have to start and stop,
and it's less flash tank load.
Damn right.
So, and even in the summertime, you'll see these fans kind of creeping down because they're trying to maintain an 87 degree drop leg temp. Okay, well, once you hit that, like, I mean, you're still pumping 87-degree liquid in that flash tank. Why not just run it the rest of the way? If you're running the fans at 50 hertz is at a 60, what is that last 10% really saving you? Nothing. It's like running, the TD strategy up to 100 degrees. What are you saving? You're not saving anything. You're just raising the compression ratio at that point.
So we all, we talked about this on the last podcast, but we were talking about the low minimum. I mean, I've seen it as low, on a lot of these racks. Typically the low minimum's 800 pounds, which is what? That's 68 degrees.
No, I've actually, every rack that we have up here is like 40 or 50.
40 or 50 what?
Degrees saturated.
Really? So I mean, I guess as long as you keep the gas cooler pressure above the flash tank to maintain like at least 100-pound differential, you're straight, right?
So yeah, it's about that. Like that's where CO2 absolutely kicks every DX refrigerant's ass is in the wintertime. I mean, because we're running saturated temps because of the way we're manipulating the whole system. Because we're already running that liquid temp down to like a 40-degree liquid temp. So everything in the store is sized for that. So say your flash tank's running a plus 33-degree condensing temperature or liquid temperature. Okay, we're already sized everything in the store that way. All the valves are sized for that TD. So think about it.
You're not going to have any load on your bypass gas valve then.
Correct. The less load you have on the bypass gas valve, the better, because you're going to have a little bit always, just for the fact that you're going to be like 635, probably maybe like 600-ish. So you're still going to have some load on it, but Brett, like the load is almost non-existent. So think of it like this. If you were to do this with a normal DX refrigerant and you were to take and drop the saturation down to 40 degrees condensing, you would starve every valve in the store because you wouldn't have they're not sized for that pressure differential.
Yeah.
Okay, now you take that same rack that you're running 40 degrees and shove it up to 120 degrees, what's going to happen? They're all going to flood back like a banshee because now they have a massive pressure differential. Our pressure differential does not change all year round because it's maintained off of the receiver pressure. It's like the liquid outlet pressure regulators at Walmart. They're maintaining the liquid quality and pressure at the same all year round.
Yeah.
So that's why you could tank the head on these racks and not have a problem.
Yeah. Oh, you know what? Someone called me today because he was trying to figure out this theory. He had a HPV that was reverse. It wasn't reacting. It was supposed to be closing down a little bit, and it wasn't. And the complaint that they had is that it kept continually having oil failures. And we were talking about it, and I ran it by Joe because I had a theory on why it was doing it. Because my thought was if you're running really, really low pressure and you're trying to kick on all these compressors, you're basically going to have a shit ton of velocity going through there. If you have too much velocity over the rated discharge CFM that you're supposed to because of your velocity, I'd think that would end up causing, lots of velocity going through the compressor, which essentially causes oil carryover. Because once they got the HPV, programmed properly, rack settled down, the bypass gas valve settled down because that was cranking at 100% because it was just overloading the flash tank, put too much of a load on it.
So you could actually overwhelm a coalescent filter. Mm-hmm. So remember, I was talking to Adam Westermeyer about this because we had a rack that there was some like engineering mess up and they undersized the filter by a lot. Mm. And I was thinking, and me and you were thinking, like you were talking about it, like it was actually it should have separated better. It's loaded up like more than 100%, but it actually takes the oil and atomizes it too fast, and it doesn't give it time to drop out.
Well, that's what I was thinking. Like it had to do something like, the velocity is kicking, where it's just kicking it up so bad. It's like running a mixer, right? You can run a mixer at a certain speed and it still, remains almost like liquid. But if you kick that mixer in a high speed, it basically atomizes that liquid, which probably make it travel through the separator, right?
It does. It doesn't give it. So, okay, like a Temprite or a Westermeyer separator, like a coalescent style separator is it atomizes the oil. It pushes the oil through the gas and oil through there, it atomizes. It causes it to like separate and drop down. Well, if it can't drop down and it's moving too fast, it just carries it right back out the pipe.
That makes sense.
Yeah.
Well,
So
I mean, that's what we talked about. That's what we thought it was. And I was just like, I don't know. It sounds like a pliable theory, but let me talk to Joe, because that's usually what I'll do. I'll come up with something stupid that I think it is, educated guesses, based off of the other stuff that they're seeing. And then I'll call Joe. I'm like, am I an idiot, or does this actually make sense?
yeah, I mean, that's one thing. Like CO2 is like, if you don't have that differential between the flash tank and the compressors and the oil reservoir and the compressors, you're going to have nothing but oil issues. 100%. You got to have that differential. And if you don't, I mean, 60 pounds is usually my limit. I don't want to see it under 60 pounds. You start getting under 60 pounds, you start getting into nuisance issues. I try to keep it 70, 75-ish pounds. You'll keep the nuisance issues away. But yeah, if you float that head down and you get that head pressure down, you'll be in a world better. I mean, that gas cooler is great. We've taken a couple stores, and especially where they have had head pressure issues in the wintertime, we've taken the gas cooler fans and split them up. Like I'll drop out fans. So, and I'll set it up where it can cycle fans. And I'll tell you what, we've made the thing tremendously more efficient. You're saving the life of the fans because they're not stopping and starting so much. And then you are just, you're running one fan. I'd rather run one header fan, 40, 50%, and then have the other fans off. It's more efficient to do that than stop and start fans all the time. And it's just taking and reducing the failure rate on those fans.
So let me ask you a question then, because a lot of times you have a V style gas cooler. Are you shutting off a certain side then? Or are you systematically shutting off, like if it's a 6 fan, what are you doing?
So if it's a V style, I'll bring them down the row. Like, so if it'll start like a normal condenser, I'll take down number 6, the number 5, the number 4, the number 3, the number 2, and then leave number 1 running. And then as the load increases, it starts adding fans. It's still, your drop like temp's still good, your saturation's still good. I mean,
You're just getting better control by jumping that 10 volts over to the thing, shutting it down at 0%.
Yep. 100% better control.
Hey guys, question number 2 for the month of November. What's the proper superheat on the transcritical compressors as well as the subcritical compressors? Let me know. Email your answer to arpgiveaways@gmail.com to enter to win.
Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westermeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode. Hello guys, this episode is brought to you by Fieldpiece. The tough wireless vacuum gauge MG44 from Fieldpiece is engineered to give you the reliable reading you need and the ease that you want. Confidently measure vacuums with a reliable leak-proof seal. The MG44 can be used with the JobLink system app from up to 1,000 feet away. This easy-to-read backlit LCD offers a graphical representation of the vacuum progress, even in low light or at odd angles.
Visit www.fieldpiece.com for information or follow us on social media at Fieldpiece Products. Thanks again and enjoy the episode. So, well, all right. So how do you do that then? Because a lot of customers are going to come at you and be like, you know what? No, you got to do it exactly how this is. I'm assuming you're only getting involved in doing this when there's an issue. Yes.
So we're getting involved doing there's an issue, and then I have proven to 2 customers up here that it runs better, and we get better control out of it.
You wouldn't have flashed, intermittent flash tank, levels too, because it would hold a certain level in there.
Correct. All the LMP, all these LMP did it up here.
Mhm.
We did it on startup, and it worked amazing.
Wow. So
very easy to do.
yeah, so all you need 6 relay outputs, right?
Yep. So what you do is you get a relay output board with an AO on it, and you wire one AO, so your speed signal to normally closed, and you wire your other AO to normally open.
Mhm.
And when the fan switches off, it switches the relay off, and then it puts 10 volts to it.
Sweet.
It's super simple. But now we're going to go over gas coolers. We're going to go over the Guttner condenser. Everybody's seen it Target. Now, I will say this. I have not seen one of these come out programmed yet. So you got to get they're fairly easy to program once you've done a couple of them. The one guy I got was amazing. Great guy. If you get the program and it's actually programmed, you're golden, but half the time it's not. A couple things, just make sure the thing's not in manual mode, and then make sure on the right AI, because there's like 6 different AIs on there, 5 or 6 different AIs in there. So make sure you land on the right AI, and that's what it's going to be controlling it in slave mode. Now, I will say this. That controller can run in standalone mode and control it on its own. So there is a sensor that's supposed to be landed on the drop leg next to your sensor for the CPC control or microthermal control. I run that. It's not on any customer's prints here lately, but I still run it. So that way, if there is an issue, say you blow up an AO board and you don't have another point, you could at least run this thing in standalone mode. And it's super simple because all you got to do is switch it to standalone mode and give it a temperature set point.
And that's that. I'm pretty sure someone just called me about that today, and they said it was a PT1000 sensor.
I believe it is. So, I mean, it's been in the cabinet on every single one of them. So, I mean, I would just install it and then insulate it right next to the high pressure valve controller and or your drop leg temperature sensor for the rack. I would just put it right there, right next to it. Put all 3 of them right next to it. I mean, it's cheap insurance and a backup for you. I mean, the one thing I do not like about those condensers is the pump and dump, which it's good.
Make sure whenever you're doing any of these condensers, gas coolers, whatever, because a lot of these, the racks right next to the abatic, there's usually piping in between. Please insulate the line, and as well as insulating it, also use reflective tape, because what will happen is if you don't use reflective tape, the black Armaflex tape or the black Armaflex that you used is going to absorb all that heat and screw up all your numbers. So advice, put some reflective tape on there. It'll make your life easier.
Yeah, to be honest, at all the Bullseye stores, though, it's inside the rack, which I have literally seen this at multiple sites. It makes no difference.
No, but if you're getting beat down on sun, it will.
I don't know.
Yes, it will.
I've seen it at Costco on Costco roofs where they're literally metal shining on there, and it makes no difference on the rack performance.
Okay, devil's anus. I'm just saying, like it's very bad.
Here's the reason it doesn't. Okay, when it's that hot where it's going to make a difference, guess what? The fans are running 100% already. So it's apples and oranges. So I prefer to have it at the rack so the temperature sensor isn't picking up any heat.
Okay, but if it is.
Okay, we all don't live in Texas. Not everybody lives in Texas, and there's like 4 CO2 racks in the entire state of Texas.
It's not true. We're up to like 12, I think.
12.
Just started being able to put them here, man.
So Yeah, with that being said, like, so these Gutner condensers, you have this pump and dump system. So what they do for the adiabatic, they have their own controller in there, and they're controlling it off a dew point outside. And then once it gets to a certain drop lake temp, it starts injecting water all the time. Now, with this being said, there's two BLEMO valves. There's a fill and a drain. Not one of these has come out right yet. So either they're flip-flopped or they need adjusted. So you need to make sure the fill and drain are right. So what they're doing basically is they're filling water straight from city water, pressure, and they're taking water and dropping it over these pads. They wet the pads, and then once the pads are wetted and any excess water goes into the drain pan and just drains down the drain. Just dumps it right down the city drain, which is insane because they're using quite a bit of water. And good.
I don't understand why there's no regulator or anything like that.
It's insane. Like it's literally just dumps it right down the drain. I mean, and it's not like an astronomical amount of water, but we had a customer put a water meter on, and they were using thousands of gallons of water a week.
What? I don't get it.
And then, like, okay, we have really bad water out here in Chicago. Like, it's really hard. So, I mean, those pads are going to be trashed. Like, there's no calcium cleaning on there. So, like, those condensers, and then they have two different controllers in there. So you have one fan controller, and you have one that's just doing the water. If your humidity sensor goes bad, it completely locks out the water. And the only way to get it on is by actually taking the valves off and the actuators off and forcing them on.
What actuators are you speaking of?
There's two BLEMOs that I'll fill in a drain.
Oh, okay.
So like there's a manual drain for it to where it'll drain it, and it'll drain the water line, so that way the headers drain.
Analog out for the BLEMO, or is just 24 volts?
Just 24 volts on, 24 volts off.
Okay.
So now if you're doing the bullseye stores, kind of like ask the plumber so nicely that when he's doing this to cut a T in with a ball valve for a hose bib. So that way, when you have to clean this thing or the rack, the hose bib and the target isn't like 6 hours away. You have a hose bib right there.
Yeah.
Which has been like phenomenal. Like the last three I've done, I went and bought the hose bib pieces. I mean, I'll spend $15 to have a hose bib at the rack for the next guy. Well, I mean, think about it. I mean, you got to clean those pads. I mean, and those things are microchannel in some spots. We've had a lot of leaks though with those things too.
What's that?
The Gutner coils leaking.
Really?
4 of them.
They're stainless, aren't they?
Yep, they got to come out and take them.
Oh, that sucks.
They send a crew out and they take them back together. So I've not had a lot of positive interactions with those things. They're okay. They do work. The majority of ours are Modines.
Really?
Yes.
I didn't even know that was the thing.
They work great. Easy. They have these like cheaper ECM motors. They're very easy to work on. They're easier to get. I mean, that's what Hill pushes, is these Modine condensers. They're just standard air cooled gas coolers.
I've never even seen
them. Straight European design. Now the BACs, I've only seen one. So the BACs are the same as a BAC. I think they're called, are they tritiums?
Trillium.
Tritiums. Those things work pretty good.
Yeah, so those work on so where the Gutners, I believe, are trying to achieve a certain humidity with their controller. Is that correct, Kev?
Yeah, they're trying to maintain a certain dew point. And then once it gets to a certain temperature, it just dumps to, try to keep it as cool as possible.
So what they usually do is they go through a pre-cool mode. So like it usually runs with no water below, whatever the pre-cool set point is. So let's just say 74 degrees. And then that way, after 74, then it starts filling. There's I think the bottom, it's like a 20-gallon sump in the bottom. And then there's almost like a sump pump in the bottom. Actually, that's exactly what it is. It's sump, and it pumps the water, and it pumps that water up and around up through the piece of PVC, which go to another piece of PVC on either side. And all it is just a big piece of white PVC with holes drilled at the very tippy top. I'm sorry, at the bottom of the PVC. So when it is cooling and is dropping that water down across there, it's able to spread all that water around evenly to those I guess you call it the pre-cooler media. That'd be correct.
I think so. Media. I
Yeah.
don't know what you would call it. Like the pads.
Yeah. I've seen. I think it's called media.
Now,
But
one
anyway.
with those guys, let's throw this in here. Same with the Gutners is make sure they're clean. They get cottonwooded up really easy.
So one thing you can do for the BAC, I know they sell this as a kit. If anyone's ever worked on some of the Munters units, usually there's on the condenser side for usually the condenser side that's used for the regeneration on the Munters units. They have this black material that can get attached to the side of the gas cooler, so it's like a filter before it hits that actual water media. If I were you, I would get it. I know it sounds like, oh, it's just going to clog up, but it's a lot easier cleaning that than it is to clean the actual freaking panels, especially when they have water in them, because they usually weigh 20 pounds with no water in them, and 100,000 when they have water on them if you're trying to fucking clean them.
Oh yeah, and they're a pain in the ass to get on and off too, especially by yourself in the middle of the night trying to clean those with a garden hose and get them clean. It's a pain in the ass. I'd much rather clean the black things and then have an apprentice clean those once a year. We honestly replace them. Like if they're all like gummed up, we don't even waste the time. We just change them.
So on these things, there is a water pressure regulator. I'd have to I don't remember what pressure it's actually set for, but be mindful in that little regulator. There is a screen that you can disassemble that, so if it's not giving you enough flow of what it should be, it could be that screen material is messed up. And it looks almost like, if anyone's ever taken apart a Danfoss electronic pulse width valve, basically that plastic with that little fine material on the side. It's basically what it looks like. And then there's like a little another screen material in there. So just make sure that is clear on the regulation portion of, because that's how it, lets the flow go through there. It just doesn't go through all willy-nilly. Now there is a connection if God forbid you do have a pump go bad, which on some areas it can be, pretty bad, as far as the solids that are left behind, because these things aren't treated. So any water that you do put in there that it does evaporate off, the solids are left over. Think of it almost like a coffee burner. You've all seen a coffee burner that's old as shit, and you have all that white stuff in the bottom. It's basically all the the calcium chloride that's stuck to the bottom for years of heating up. Same principle, except for it's going to drop in the bottom of the sump. That's why these sumps, they basically blow off. Usually once a day. You select the time. That's usually done through the BAC controller that's on there.
Aren't the BACs though? I've only messed with like one or two of them. The one I seen had a hardness sensor in there.
Yes. But I don't remember how to get in the program to adjust that. Yeah, they do have it's called a connectivity meter. Basically a parts per million. So if it does get over X amount, I believe it will dump, and bypass. One of the cool things is usually on these BACs, if the pump were to take a crap, you do have an auxiliary place where you can hook up a garden hose if the plumber put in, like Kevin said, and then, you could basically go without having the pump, because you're basically putting fresh, cold city water into this thing nonstop. Right. So not only do you get the added effect of, just not having to have to pump it right now, but then you also utilize the cold water coming from the city, from underground.
Yeah, from a tech standpoint, I like the BAC a lot better. It's a lot simpler, a lot easier to work on, not as much bells and whistles, and the backup system. Me personally, the BAC is a much better product if you're going to use adiabatic. But personally, I would rather just have a straight gas cooler.
Yeah.
For us, like, we're in a high humidity area, so like it doesn't make as much sense. I mean, when the dew point's high, that's almost like even down south when the dew point's that high. I mean, what do you're not really, you're gaining a little bit, but not much. I don't think the maintenance costs overweigh what the operations cost is.
As far as what, like
Like the amount of maintenance and deferred maintenance and what happens if you don't maintain them. Let's be honest. I mean, grocery stores are grocery stores. They do not the best job of maintaining certain things. And it seems like water treatment is probably the thing that gets, by the wayside the most.
Well, you know what it is. I think honestly, I think it's being uneducated. Is to be quite honest with you. I think a lot of it is the fact that you have rack refrigeration mechanics that really don't understand the whole water treatment thing. You know what I mean? Because there's a lot of different, I used to do it for a living. There's a lot of different things that are involved in it. Basically what happens is you have one material called the biocide. Okay, that kills anything. It's exactly what it sounds like. It kills anything biological, right? Then you also have a chemical that's usually dual purpose. One, it's a solvent. Basically, takes all the calcium off the pipes. And you test like how gnarly it's going to be based off the amount of part per million of that chemical that's actually in the space. And then the other thing, you have another material that's in there that keeps solids in solution longer. So if I have 2 cups of Kool-Aid right next to each other, one is treated with this chemical, the other one is not. So I'm basically going to start dumping sugar in there. And at one point, if anyone's ever made Kool-Aid as a kid, they had too much sugar, the shit drops out of the bottom and it can't be absorbed by the the water that's in there. But by adding this material, it actually keeps more solids in solution longer. The reason why they do this is basically because at that point, when you do a blowdown, which is the process of just opening up the drain line to reduce the amount of solids in the container, it has more solids in that 1 gallon that you let go of water versus something that wasn't treated. Does that make sense? No? Yes? Maybe?
Damn it! I keep muting myself in different locations. But no, that makes complete sense, and that's the hell, I just muted myself again. That makes complete sense. Like I don't understand the water treatment stuff as much as you do. Obviously, you did it, but like I mean the water treatment, like to me, it's just a disaster waiting to happen in the supermarket. In a big plant setting where they're actually maintaining things, yeah, great. It would probably work great, but not in the supermarket. Simple, air cooled.
Never another useless information. Any kind of I think every time there's an inch of schmuck in the bottom of any kind of cooling tower, since we're talking about water treatment real quick, it actually increases the amount of chemicals that you're going to use. That's why if you've ever played around the bottom of the tower cleaning it up, when you start moving all that sludge and start shoveling it out, it smells real sweet. It's because it has a high concentration of that chemical within all that muck at the bottom.
It's because you're digging up cancer at the bottom of the cooling tower.
Yeah, essentially.
Yeah.
But to be fair, anything you touch in California actually causes cancer. Actually, last time I was out in California, I laughed my ass off because I looked over to a car next to me that I was parking to, and there was a sticker on the fucking car that says, "This car may cause cancer," or has materials that are known to cause cancer.
But yeah, so guys, like gas coolers, just a condenser, guys. I mean, it's just higher pressure rated condenser. It's a condenser that only condenses half of the year. Think of it like that. That's the easiest way to think about it. Piping's just all the same. I mean, a V-channel gas cooler or a straight slab gas cooler, they both exist. I mean, all these we're doing are straight slab gas coolers. So just like a normal condenser, just horizontal fans blowing up. No V coils. Me personally, up north, I hate V coils because we get the prevailing wind, and I mean, there's no way to stop it. So you get kind of screwed with that. So I would rather just have the vertical discharge, coils. So just your standard coils. And then plus I don't want to be climbing on a V style coil where it's like 19 feet in the air, and some of those things are made pretty chintzy, and I don't like climbing on top of them. But the biggest thing, like, I really wish they would switch to standard fans because we've had a lot of problems getting the ECM fans.
Yeah, they're having a lot of problems getting a lot of stuff.
Well, ECM fan motors are like drugs. They get you hooked cheap, and then then the price to get the second hit's a lot more expensive.
That's awesome. One other thing about the BAC, if you do have shitty water in a certain area that you're in, BAC does sell another pump that you can install, and I believe like all the innards are a little bit heavier duty. I believe the actual impeller is stainless, if I'm not mistaken. So you do have that option. I would recommend at one of these things for the gas cooler, for sure, having, if it's a different sensor than just a regular whatever EMS system that you're working, have it. I would also recommend having a pump on hand. Yes, you do have that secondary, but shit happens. It's a lot, and you guys know, with now everything that's on back order and shit, and everything's 6 months, 8 months out. Good to have one just in case something totally blows.
At that point, you might as well order a fan motor too.
For sure, absolutely, and I agree with that.
I've literally been slathering the electrical components and like the electrical on the outside of those in silicone on startup, like a just complete jag off. Like I just literally just cover them in silicone. I mean, they're either nobody's gonna mess with it for 8 years, or like it's gonna fail in like a week because the water got into it, and
See, that's what sucks with the placement of these things. Because I mean, I asked that question to someone and I never got an answer, because I was curious. Like, when you have these type of motors that have thousands of dollars worth of electronics, right? You're putting these up above a heat source that's getting beat on by the sun, which is another heat source. So, like, what temperature is that O-ring rated for? That's supposed to be sealing the electrical cabinet area, away from the outside.
You know why? Because engineers hate technicians.
No, they don't. No.
They absolutely hate us. So
you wake up in the morning and be like, how can I fuck over this guy today? I got an idea. Let's do this.
You ever seen how a car is put together? It's just like, yeah, this guy has to work on this. What an idiot. It's the truth. That's why I'm a firm believer they should make some of these people that actually design this shit work in the field.
They're gonna ruin. I can't.
What?
I don't know. I just can't. All
right, guys. Well, that's gas coolers. So thanks for listening. Have a nice one.
Later, guys.